All right, so here's a simple multiple object problem where we have what's called a modified Atwood's machine. And that's just where we have one hanging mass, and there's a pulley, and then there's a cart up at the top. And maybe if you want, you could put some extra mass on that. And they're connected by a string, and we'll put them on a track so that the cart rolls straight. So let's say we know what the mass of each of the masses are. So the mass 1 and the extra mass is 20 kilograms, and the hanging mass would be 4 kilograms. And a problem like this might ask for what's the acceleration of the system. So when we're looking for acceleration, we're going to start with Newton's second law, sum of the forces equals ma, because we can use that then to solve for the acceleration, but we need to know what forces are on that cart. So not too bad, we use a free body diagram, and we know that we have the normal force up, there's a gravity force down, and there's a tension force pulling it to the right. And we're going to start in the x direction because that's the way it's accelerating, and we get the nice easy equation, tension equals mass times acceleration. And we know the mass is 20 kilograms. And then we have what the acceleration is. And this would be great. We'd be able to solve this. The problem is we don't know what tension is. So we have to try to find tension somewhere else. We can either look in another dimension. But in this case, tension is all in the x, so we can't even use the y. But that tension is attached to the second mass. So where else is that tension? Yeah, it's on mass 2. So what we're going to do is we can draw a free body diagram for mass 2. We have gravity down and tension up. And what we're going to do when we look at this is we're going to call positive x the way the whole thing moves. So in this case, when we look at the forces on mass 2, gravity is going to be positive and then tension will be negative. You can kind of think of the helping minus hurting, where gravity helps it move and tension's holding this mass back. So that's equal to mass times acceleration. And remember, what is the gravitational force equal to? Well, remember, the gravitational force, big G, is equal to the mass times the acceleration due to gravity, little g. So we can put the mass in there, 4 kilograms. And what is little g equal to? Well, little g is equal to 9.8 meters per second squared, which is pretty close to 10. So we're going to use 10 just to make the problem a little bit easier. Minus tension equals 4a. So what do we do next? Well, what we can do is we can substitute, because we have two equations that have the same two unknowns. So we can substitute that t from cart 1 in for t in cart 2. And now the question is, how does the ax for the cart compare to the acceleration of that hanging mass? Well, remember that they're tied together, so the accelerations will be the same because one can't move any faster than the other. So now that allows us to continue through with our algebra. And what we find out is the acceleration of the system then will be 1.67 meters per second squared.